this so we can learn some other things. So this will be the last new lesson in this unit. I know it's been a lot. Exponent rules are a lot. We did adding and subtracting polynomials last time. We're going to do multiplying polynomials today. But this is a big week because we've got review day and test day also this week. So number 1 says to simplify the following expression. This is exponent rules. We've got to know our exponent rules, okay? And remember, they're on our chart too, which I don't know if y'all picked that up, but we'll want to pick that up the next couple classes so that way we know how to use that. So remember, the first rule I'm really checking for is if there's an outside power and I multiply those in. Do we have an outside power on number 1? So I just take that outside power. Now the whole thing's in parentheses, which means the outside power goes to all of these. So I'm drawing my arrows to, what is A's exponent? 1. What is 3's exponent? 1. Give those ones as well. Okay, I think that will help you with the big numbers. So I'm multiplying those in. And I would take this in 2 steps, guys. I would not try to do this all in one time. So on the top, it becomes a to the 4 times 2.
2. 8. Oh, 8. I was already like.
B to the, I'm going to go step by step. B to the 4th, and then C to the, what's anything to the 0 power? 1. Do I need that? No, don't even write it down, okay? If you do write it down, just mark it out. Because 0 times anything is going to give you a 0 power, which means it's going to become a 1. Now on the bottom, the 3 is a regular number, and it had an exponent of 1. This is going to turn into 3 squared, which we will use our calculator and evaluate that, but we'll just leave it like that for a minute. On the bottom, it becomes a to the 1 times 2 is, b to the 3 times 2 is, 5 times 2. Okay. And so then I want to clean up from here, and I am now going to apply my quotient rule because I've got a fraction, which means you're either subtracting the exponents, top minus bottom, or you can kind of think of it as tug-of-war. I think tug-of-war is a little bit faster. But I do want to kind of clean that up. What is 3 to the 2nd power? What number is that? How do you get that number? What do you do?
First you put the 3.
3, caret, 2 in your calculator, and that gives you the number 9. So that coefficient is going to become 9. There's not a coefficient in the top, okay? I mean, there's an understood 1, but I'm just going to work with that, and then now I'm done. Now I'm going to look at my A's. Who's going to win the battle between my A's, top or bottom? By 8 to the 6th, okay? Who's going to win between my B's? Miles? Bottom by?
Bottom by 6.
No.
Bottom by 2.
By 2. And then C, there's only 1, so it stays where it is. And this is my answer. And I'm done. Okay? The next one is the same idea. However, there are some negatives in there. Negative exponents, and there are more coefficients. I personally don't like negative exponents. I try to fix them, okay? So what did y'all do? Did y'all leave the negative exponents and fix it later? What do we do?
Well, you can't have negative exponents.
No. We can leave it for now. What about p to the 0? Get rid of that, okay? What should I do with 14 and 2? What should I give those exponents of? And give those ones. We'll go ahead. We'll just leave the negatives for a minute. We can fix them later. So I'm doing that outside power again. I hope you realize this is a common theme. We do outside power a lot. Expect to see that a lot on your test. So this is going to become, okay, on the top I've got 14 to the 1 times 2 is 2. M to the 4 times 2 is 8. N to the negative 2 times 2 is? Very good. And then P's gone. On the bottom, I have, what's my coefficient there? Is there anything wrong with negative coefficients? No. But I would always suggest that if you have a negative coefficient, what did I just write it inside of? Do that. Okay, be very careful with that. And so this becomes 1 times 2 is 2. M to the 2 times 2 is 4. N to the negative 2 times 2 is negative 4 again. P to the 6th. So that's what I have just by bringing that in. And kind of like we did with the 3 squared over here, I'm going to figure out what 14 squared is. I'm going to figure out what negative 2 squared is. Okay, I'm going to take another space here. Okay, 14 squared, I put in my calculator. And I get 196. Negative 2 squared, I put in my calculator with, what did I put around it? It's important. So important, because what is negative 2 to the second power? What kind of 4?
Positive.
Because what's a negative times negative? Positive, okay? Now, the negative exponents, I don't exactly like that they are negatives, but what happens?
You have to switch it.
Take the base, move it to the other side, and then make it, when you move to the other side, it becomes positive. But what's going to happen here? I'm just kind of leaving everything else the same. What's going to happen with my ends when I do tug of war with those? They're going to cancel out. Would they have canceled out right here? They're both negative 4s, right?
Yeah.
So because they were both the exact same number, we could have canceled them earlier. It's okay if you want to make them positive and really see that there. Either way, I think it's good to practice either skills. But they are going to cancel out because it is going to be a tie. Okay? They're going to give you a 0 power and the ends are going to drop. And so now I just got to clean up the other things. Brayden, what did I tell you to do with the coefficients when you're simplifying them? What do we put them in?
Y equals.
Alpha y equals, okay? So we can do alpha y equals 196 over 4, and that simplifies to 49. If it simplifies to a whole number, where does that go? Does it go on the top or the bottom? If it simplifies to a whole number, it goes in the top. So I just have like 49 over 1, like there. And then m's, tug of war between the m's. Nick, who's going to win between the m's, top or bottom? By 4. M to the 4th. And then p's, there's nothing else to work with, so I just leave them there. Okay? So can't stress enough to y'all about how important these exponent rules are, because they are not going away. They're going to be an entire test grade is going to be over exponent rules. Okay? So we got to be really, really good at them. And we're going to kind of bring them back today. Anybody get the solution to number 3? What'd you get?
I got -5.
-5?
Yeah.
Anyone else get that?
Yes.
That's what I had on my answer key. I'll put the work on Canvas, but for now I'm going to go ahead and skip all that because it doesn't.
There's all decimals when I realized it, so.
There's decimals? I'll work it out and I'll put it on Canvas too. Okay, let's flip back over real quick to page 14. This is what we did last class. I'm not going to spend a whole lot of time because I really want to get into the new stuff, but adding and subtracting is what we did last class. It was just combining like terms. So I kind of want you to go through this and answer these just real quick. We don't have to write a novel. Like, I think this needs to take like 3 minutes. Just kind of answer these. What does it mean to combine like terms? Why are x and x squared not like terms? What do you have to be careful about with subtracting? How are adding and subtracting differently? Or how are they different? If y'all will try to go through and fill that out so then we can move on to multiplying, let's go ahead and do that real quick. If you need to flip back and look at what we did when it came to adding and subtracting, do that. But try to kind of brain dump on that. 3 minutes, ready, set, go. Okay. All right, let's just go over this real quick again. I just kind of want this to be like, you can put what I put, you can add to what you put, you can just listen. It's just kind of a like, let's just get our bearings, see what we did. When we combined like terms, all we ended up doing was just adding up the coefficients of the like terms. I want to put a note. I do think probably write this down. When you combine like terms, you do not change exponents. Do not change the exponents. They are just an identifier that tells you, hey, these are alike because they have the same variable, the same exponent. We don't touch the exponents in adding and subtracting. It's going to be a little bit different today when we get to multiplying, okay? So all we're doing is just putting the coefficients together. X and x squared are not like terms. X has an exponent of 1. X squared has an exponent of 2. They're not the same, okay? With subtracting, you got to make sure you distribute that minus sign to everything after it. It's like multiplying in a -1. All it does is change things from positive to negative. But other than that, adding and subtracting are very similar. It's just with subtracting, you've got that extra step of distributing in the minus sign. So, again, this skill isn't crazy, crazy hard. It is something that's going to be tested on this week, but we'll review it next class as well. But we are going to move on and get to multiplying. So just so you are aware, before we jump into multiplying, here's a plan. We got one more lesson. The goal is to try to take an exit ticket at the end. We'll see how time allows for that. And then next class is going to be review day, and I have tons and tons and tons of stuff for review. It's all on Canvas. Don't know if we'll get to everything during class, but if you are working outside of class or in tutorials, we have lots of stuff for you. We're probably going to be doing like some group work too based on how you did on those CFUs. Like me or Coach Holt might be kind of going with y'all to kind of make sure we're good and clear up any things that we've been missing. The test will be 2 separate grades, okay? That's the plan. So moving on, flip over to page 16. Okay, and today on page 16, we're going to be talking about multiplying polynomials. Go to page 16, please. Flip back over. 7.4, multiplying polynomials. All right. There is some stuff that's going to be a little bit familiar to you that you have seen before. Distributing is what we're reviewing at the very beginning, and we will see distributing in here as well. But there's a little bit more to it because of the variables. So there's a little bit of old stuff, a little bit of new stuff, okay? In my experience, a lot of times, like when we teach this lesson, I don't know what it was last year, but I had 3 Algebra 1 classes last year, and they were all, like, loving this. I don't know if I was just, like, super teacher that day and everyone was happy, but it's usually something that, you know, once you get it, you just kind of roll with it, and it's not too terrible. And I don't know, last year they kind of thought it was fun. So the distributive property is when we do what? Y'all do your little rainbows, and we know that means distribute, but what operation are we actually doing from the outside to the inside? Multiply. So we multiply the number on the outside, parentheses, to, I think that's supposed to say all the terms on the inside, okay? So it goes to everything. Now, what's going to be a little bit different today is it's not just going to be numbers outside. We are going to start multiplying in variables as well. So there's going to be a little bit more to it. But for this, we've got 5 times x minus 3, and I need to take my 5, I got it. Take my 5 and multiply that into everything on the inside, okay? Which we should know how to do this. So 5 times x is 5x. 5 times negative 3 is negative 15. If you need to go, you can go. Just go fast because we're still going, okay? And then, is there anything I can do with 5x minus 15? Can I combine those? No, can't do anything? There's my answer. Done. Moving on, okay? But let's talk about what happens if I start to multiply a 5x. This is what's a little different, a little bit new, okay? 5x, I'm still distributing. It's still set up the same. You've got something outside parentheses, something inside parentheses. I still got to multiply to everything inside the parentheses. I'm doing 2 arrows. None of that is changing. However, because I have an x, I kind of got to think back to my exponent rules. Essentially, what's going on here is I'm multiplying 5x times, what's the coefficient right here on this x? 1x. So my exponent rules say I'm going to multiply my regular numbers, which are 5 and 1. So what's 5 times 1? 5. But then I'm going to multiply x to the 1 times x to the 1. What do your exponent rules say when you are multiplying with the same base? What do? You add them. And so this becomes, I write down my base x, and then what is 1 plus 1? 2. So this becomes 5x squared. Does that make sense? Okay, so my exponents do change when I'm multiplying, but that's because, look at the names of your rules. Exponents will change when you're doing a product, which means multiply, when you're doing a quotient, which means divide, or when you're doing an outside power, okay? Those are the rules that exponents will change. And it just becomes a simple addition, but what you're going to see a lot is that x times x is x squared. I want y'all to write that with stars up here. X times x is equal to x squared. That is something that we have to have memorized, okay? And the reason why is because x and x have an exponent of 1, and 1 plus 1 is 2, all right? So that will happen quite a bit. Now, when I multiply to my second term, this becomes 5x times negative 3. I don't have another variable in there, so I'm just going to stick the variable with the number. That's not really anything new. But what is 5 times negative 3? No, 5 times negative 3. It's negative 15, just like we did over here. But then this one is going to have a x on it because I have to bring that outside x to the inside. like that. Okay? And then that will be my product right there. Why can I not combine x squared and x? Are they like terms? No, we already know that. Okay? All right, this one. We've got 2x. Y'all remember the name for that vocab word? It's one term, so what does that mean it is? Monomial. Very good. What's this guy? X squared plus 2x plus 6. How many terms are there? That's a trinomial. So how many times are we going to multiply here? 1, 2, 3. So what I'm going to do is I'm going to multiply the big numbers, add the exponents. Multiply the big numbers, add the exponents. Big numbers, add the exponents. Okay? So think about what 2x times x squared. Zane, you got an idea? Heidi, got an idea? Braden? What do you think?
So the first one's gonna be 2x 3.
Why?
Because it's 2 times 1.
2 times 1 is
2x.
2.
And then you add the
And then you add x to the 1 times x to the 2. 1 plus 2 is 3. You multiply the big numbers, add the little numbers. Okay? All right, Zane, try this one. 2x times 2x.
That would be 2x 2.
Halfway right. What's 2 times 2?
2x 4.
No. What's 2 times 2? Big 2 times big 2.
4x 2.
4x squared. There you go. Very, very close. Okay? So 2 times 2 is 4. X times x is x squared. Okay? Daniel, got the last one? 2x times negative 6.
Negative 12 and x.
Perfect. Perfect.
and then you just add them all up.
No, we can't add them all up because x to the third, x to the second, and x to the 1, those are not alike. You can only add when they have the same exact variable and the same exact exponent. Okay? So 3, 2, and 1, those are all different. And we leave them just as is. Okay? All right, try the other one. There's 2 things there. You might have some like terms on this one. Now remember though, it only multiplies to what it's attached to. So you distribute there.
But what if you add the negative 12x with 4x?
You can't, because this is a 4x squared. And this is a 12x. Those are different.
You can't add them together.
Nope. You could only add an x and an x, or an x squared and an x squared. They have to be the exact same. Okay? So here we're distributing 2 things. Nick, you with me?
Oh, I guess.
Pick up your pencil. You're supposed to be doing this. And so if you kind of look at my distribution arrows here, those will give you a hint on how we're going to do this. All right, so this one was a little bit different because we have 2 distributions to do, and this is kind of leading us up to what our problems are going to look like, okay? What happens when we multiplied 2x times x? Ethan, what'd you get?
2x to the second power.
2x to the second power. Very good. What about 2x times 5?
I got 10x.
Positive 10x. And notice I always want to keep those signs. I have to have signs in between my terms. Okay, we have to write those in. Now, this second distribution, what am I distributing in? What kind of 3? Negative 3. So kind of keep those together. If it helps to circle that, then go ahead and do that. And what'd you get, Kalina, when you distributed that? Perfect. Okay. Now, Brayden, you've been wanting to combine. Let's look here. I have 2x to the second power. Do you see anything else in here with x to the second power?
No.
So can I combine anything there? No. So 2x to the second is going to stay. And I do want to put that first, because if I'm in standard form, I want to have the highest exponent first. But then I have a positive 10x and a negative 3x. Are those like terms?
Yeah.
Why?
Because there's only one.
Because they both have x to the 1, just plain x, okay? Now, so I do need to combine those. I don't want to leave those separated. So when I combine like terms, I'm going back to what we did last class, and we just add up the coefficients. When we're adding or subtracting, the exponents do not change. It's only when we're distributing in that they change. So 10x minus 3x. How many x's is that?
7x.
What kind?
7x. Negative.
No.
Wait, I don't know. Positive?
Positive.
Oh, you're confusing me. I thought that was.
No. It's positive because there's positive 10, Negative 3. So it'd be 7x. And then anything to combine with minus 15? No. So that's my final answer, that trinomial. I'm going to label this as standard form because I don't feel like I did a very good job last class for y'all. We saw it on the CFU and everyone was like, what does that mean? Standard form is where you have your exponents in order from highest to lowest. So if you look, I have my x squared first, then my x to the 1, and then I don't have an x. And this is what you're going to see a whole lot, is this standard form up here of a trinomial. So this idea of multiplying twice, we're going to continue to do. We call this double distribute because you distribute here, and then you combine. When you're combining, exponents don't change. When you're distributing, they do. Okay? So flip over. And now what's going to be a little bit different is that we're no longer just multiplying monomials on the outside to polynomials on the inside. Remember, a monomial is one term. Every single problem on this other page, there was just a one term hanging out on the outside. Okay?
Would it be one time? Would I should be one on that?
Where?
On these, or no, I just time it, multiply those.
Are you on this page?
Yeah.
Let me explain. Okay? So what we're going to do here, and let's just look at this first problem. When we have x plus 4 times x plus 8. First of all, how do I know that these guys are being multiplied? And this is not an addition problem like last class. Because they have parentheses. Is there anything in between here? No. Last class we would have pluses in between parentheses. We would have minuses. You got to pay attention on what type of problem this is asking you to do. So I'm going to put an M for multiply. Okay? Just like on the other ones, I would always circle the sign and say, oh, I'm adding or oh, I'm subtracting. When they're side by side like this means multiply. Okay? Now, what's different about these are that I have what's this vocab word? Two terms. What's the two-term polynomial called? Binomial times a binomial. Okay? So in order to do this, we're going to do what we call double distribute. Go up here. We're going to talk about it. Write this in because I want you to know what I'm saying. Double distribute. This is not the only way that you can do this, but this method kind of coincides well with what we're going to do in a couple weeks. So we teach it this way. It seems a little bit complicated at first, but I want you to just kind of listen through and watch what I do, and we're going to break it down. So basically what has to happen is that both of the terms in the first binomial have to multiply to both of the terms in the second. Okay, we have to make sure we get all that multiplication. We're going to end up doing 4 multiplications when it's all said and done. So our steps are going to be to take the first binomial and we're going to split that binomial up. Okay, so let's go ahead and we'll just look at x plus 4 right here. And I'm going to draw an arrow and I'm going to put the first term, which is x. And then I'm going to draw an arrow over here. I put the second term, which is plus 4. Okay, I'm just separating that out. Are we okay with that? Always split that first one. Now, it says split the first, repeat the next. So now I'm going to go in and I'm going to put my second binomial next to each one of those terms. So I have x plus 8. And then I'm also going to bring down the x plus 8 to the positive 4. Okay, I want you to kind of look at that for a second and see what I did. I wrote the second binomial 2 times, okay? Second, write twice. And then the first one, I just peeled it apart like this. Are we okay with that? This is the weirdest part of the whole thing. I promise after this, it's not that bad. But being able to start it sometimes is a little bit confusing. Are we okay? So now it's going to look kind of like the last problem that we just did. And how many distributions are we going to have to do? Boom, boom, 1. Boom, boom, 2. Okay, double distribute. So I'm going to go here and I'm going to multiply x times x, which we know. What is x times x, Jahan? Do you know? X what? You might have been in the bathroom when we did this. X times x is x squared. That is so important. Okay, so this is going to become x squared. Got to distribute x to positive 8. Emma, what's x times 8?
8.
8 what? Times x? Should be 8x. Okay. We okay? All right, now I'm distributing a positive 4. Daniel? 4 times x is?
4x.
Positive 4x, so I got to put the sign. 4 times 8, Ethan?
32.
Very good. So how many multiplications did I just do? 1, 2, 3, 4. That's what's going to happen every single one of these that you do. But what happens in the middle? What do I have right here, Brayden? Keep picking on you because you're the one who really noticed this. What happens in the middle? What are those? Combined like terms. Okay, so we drop down the x squared. 8x plus 4x is 12x. 32 also drops down. And these are the same. Okay. So essentially what has to happen here is we just have to make sure that both terms in our first binomial end up multiplying by both terms in our second. And that's why we pull it apart and write it twice. It's a little different. But if you kind of keep going through that process, it just turns into 4 multiplications and an addition in the middle. Okay? All right, let me help you set up this next one, and then I want you to try the multiplication. All right, x minus 3 times x minus 2. Again, why is this a multiplication? What are they?
Parentheses.
Side by side parentheses. So I'm going to put an M for multiplication. Okay? And I'm going to pull apart my first binomial. Miles, what's my first binomial?
X negative x minus 3.
Okay, so I'm going to bring x over here. I'm going to bring what kind of 3 over here? Negative 3. Very good. Okay, now my second binomial, I'm going to write how many times? Second, write it twice. So I'm going to put x minus 2, x minus 2. That's the one that repeats. Okay? Split, repeat. Split, repeat. Now, double distribute. Watch the minus sign. Ready, set, go. Okay, so check right here. Here's what I got when I did my double distribute. X squared minus 2x minus 3x plus 6. Why is it a plus 6?
Because negative times negative.
Negative times negative is a positive. I feel like I say that 800 times a day. Okay? And again, we do this every day in Algebra 2, so this skill is so very important. Now, I'm not all the way finished. I'm not simplified in standard form. I underlined my 2 like terms right here. Negative 2x and negative 3x. And Miles, would y'all say that combined to?
Wait, negative what?
The middle 2?
I said combined to negative 5x.
Very good. Okay, so I want you to really, really pay attention to the problem. The first 4 things you're doing are multiplications. Multiply, 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 but then you add up in the middle, okay? And this is typically what they will look like there. All right, let's look at this one. 2x plus 3, 4x minus 2. Is this still a binomial times a binomial? 2 terms times 2 terms. We're going to do the exact same thing. We've got some coefficients now in front of our x's, but that's okay. We can handle it. So we're going to split. First term. Split the second term. That's a positive 3. We're going to rewrite. Zane, how many times am I going to write 4x minus 2? 2 times. We're going to have a little more multiplication to think about here because, again, there's some coefficients on your x's, but it's still the exact same process. Multiply, 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 and then we combine in the middle. That's the flow. All right, Heidi, tell me what you got with your first distributing here.
I got 8x minus 4.
8, okay, hold on, you're distributing an x right here, so this should be 8x squared minus 4. There's going to be an x on that one. And you guys, if you set it up like this should kind of be the flow typically. You're going to have an x squared because there should be 2 x's being multiplied. This one's going to have an x, okay? Issa, you want to do the next one? The next distribute? What do you get? You got it. Okay, well, help me with it. I'm going to multiply. I'm multiplying in a positive 3. 3 times 4x is
12.
12 what? Okay? And then 3 times negative 2,
6.
what kind? Positive times a negative is a
Positive. Wait, no, negative.
negative. There you go. See, you can do that. Okay? And then in the middle, I'm going to combine again. So how I'm going to grade these when I'm looking through your stuff is I'm always going to be checking these 4 terms. If these 4 terms aren't right, then your combining probably isn't going to be right. Okay? So make sure you're showing that. Jahan, what'd you get for your final answer? What do those combine to be in the middle? Negative 4 plus 12 is... Put your calculator if you don't know it. Negative 4 plus 12. And then what makes them alike? They both have a... And there we go right here. Okay. Do y'all know there is a way to check this in your calculator? Are you interested in seeing that?
Yeah.
Yes.
I think there's a lot of this test you can, well, this topic of your test, you can. Okay, so if you are interested, we'll just do this one right here. Okay, here's how you can check these in your calculator. If you go to y equals, okay, I suggest you do this with me. Go to y equals, and I want you to type the original problem that's like the side-by-side parentheses. Okay, so what's in ink? So I would do 2x plus 3 and 4x minus 2. If you put that in y1, okay, just the original problem. And this works with adding and subtracting too. It just takes a little bit of time. I wouldn't do any checking until you finish all the problems, but this is how you can check it. And this is going to be a skill that when we get to star review, we're going to be talking about a lot. So let's put that in y1. Then we can put our trinomial, our answer, in y2, which was 8x squared. And there is a x squared button right here. It's diagonal to the 7. So after you type x, it gives you an exponent of 2 pretty fast. You could also do the caret. That works too. Plus 8x minus 6. So I put the original and I put my answer. Original in y1, answer in y2. And if these two guys are the exact same, if they are equivalent, which is really what we're doing, we're not solving anything, we're just kind of writing them in different forms, then what will happen is when I go to the table, everything should match. Okay? Do you remember how to get to the table?
Is it second graph?
Second graph, very good. Second graph, if I look at y1 and y2, the blue column and the red column, all of those numbers are matching. -6, 10, 10, 42, 42, 90, 90. That means that what I have in my y1 and y2 are the same. That means I did it right. If I look at the table and stuff is different, I did it wrong. I made a mistake. So it takes a little time to go and type those in, y1 and y2, but I think that's a great way to check and see. Again, when you finish your test and have time, maybe then you can go back and check those out there. Yeah.
My thing for some reason error. I don't know why.
It's probably a minus and negative situation. Okay? All right, let's talk about this one real quick. I'm going to put a star on this one. And then we're going to do some on the back, okay? There's only a couple more on the back. But let's talk about this.
Do you distribute the 2 and then do eta?
No. So here's what's kind of tricky about this one. And again, Algebra 2, we do this every day. And sometimes we still make this mistake here. So on our warm-up, I don't want you to flip, I just want you to look at mine. On our warm-up, we did a lot of stuff with outside 2's. I know there was a bunch of different bases in here, but in this parentheses, look at mine. Is this a binomial or a monomial, this whole thing? Even though there's a ton of different bases. Are there anything being added or subtracted inside this parentheses? No. So, Brayden, here's to answer your question. What's different about this problem right here is how many terms are inside the parentheses squared. How many terms are there? Terms are separated by pluses or minuses. So 4x is 1, 3 is another. There's 2. So this is not the same exponent rule that we did on the warm-up because that was just one term. Now we're in 2. So here's the only thing that you need to know about this. and then everything else ends up looking exactly like it does in the other problems. When you see a binomial squared, a two-term squared, all you need to do, you guys, is write the binomial, 4x minus 3, twice. That outside power tells you how many times to write this, and then it becomes just like the other problems. Okay? You split the first parentheses, you rewrite the second parentheses. Does that make sense? Write it twice. You're going to see it. You're going to see it today. You're going to see it next class. You're going to see it on the test. Write it side by side. And then now let's do our split. So take the first term. Miles, what's the first term of our first parentheses?
It's 4x.
4x. What's the second term of the first parentheses?
3.
What kind?
-3.
Okay. And then I'm going to rewrite 2 times. What am I going to rewrite, Zane?
The 4x negative 3.
4x minus 3. That I write twice. Maybe that will help if, oops, we underline that or something. Okay? So it becomes exactly like these other problems when you write it twice. And then you just distribute. Let's do this one together. 4x times 4x. 16x squared. 4x times negative 3. 4 times negative 3. Negative 12x. Negative 3 times 4x. There's a repeat there. What's that, Miles?
What?
Negative 3 times 4x.
Negative 12x.
And then negative 3 times negative 3. Negative times a negative. It's a positive 9. So it still turns into 4 multiplications. Be careful here. Are these going to cancel, these two like terms? So those cancel out?
They're gonna add.
They're going to add. What are they going to add to?
Negative 24.
Just a bigger negative. Okay? So don't just assume. Sometimes people see that and they're like, oh, they cancel. I'm like, not quite. Okay? It would cancel if they were negative 12x plus 12x. But these are just going to combine. So 16x squared minus 24x plus 9.
I got all that but 9 because I did 4x and then 8x and then minus 6. And I did
where'd you get an
4x
8x?
parentheses 8x minus 6. I got all that, but I just didn't get the 9.
I don't have an 8x anywhere.
Huh? Well, it's because I just distributed the 2 and everything.
Okay, you can't do that there because it's a 2 terms. So this is and again, it's details. There's 2 terms. If there's something being added or subtracted, this is a write it twice and double distribute. Okay? All right, let's flip over. There's a couple more problems that I want to do here. So last year on the STAR test, there were some questions that kind of threw some geometry at us, okay? And I don't want that to stress us out. I think I just kind of want to show you some of these and we'll work them together. We'll try one of these challenge questions at the bottom and then that'll be it. And we're going to try to do our exit ticket, okay? So it does say up here to put your answer in order where you have something x squared, something x, and then something. Those actually fill in as A, B, and C. We'll talk more about that later, but it's on there. So this is your standard form right here. Go ahead and label that so you have a good place. Standard form. And if you do, you're multiplying the way that the process we've been using. Everything kind of ends up in that way anyways. But you want to keep your x squared term first and then your x's and then there. So here's an application for you. This says find the area of the rectangle, and it tells you that area is length times width. But if you look at this, our length and our width are binomials. So if I want to find the area, I need to multiply x plus 5 to the width, which is 2x minus 4. Okay, that's all I'm doing is just following my formula. My formula says you multiply these. I write them as a multiplication side by side. This becomes a binomial times a binomial. Y'all see the exact same problem that we've been doing on the other side. Okay, what do we do when we have a binomial times a binomial? double distribute. Okay? Do it. Multiply this out. Was that terrible?
No.
Taking that from an application problem? No. We just plug in, do the algebra we've been doing. Okay? Double distribute, get a final answer here. This next one doesn't have a picture, but we'll set it up together, and again, we'll multiply it out. So this time we're creating a triangular garden in the backyard. She needs to find out the area to figure out how much space it's going to take up. The length is 3x plus 2. The height is x minus 2. This is supposed to say what is the area. Go ahead and rewrite this. Typo. Okay. Now, this time I didn't give you a formula, but do y'all remember what the area of a triangle is? Anybody? That's volume of a rectangular prism.
Length times width
Then what?
times base.
No, it's times like the middle thing. Like you put like a line.
That's base.
Hey, if you look
Let
at
me
this
take this.
rectangle, yeah, you look at this
Here's
rectangle.
geometry background.
What's the formula for this?
A squared.
Length times width, right? It tells us we do the length times the width.
What I said that.
That's for a what shape?
Rectangle.
Rectangle. Now, Miss McCartney, if you would draw a diagonal. Okay, what did she just do?
Times
Oh,
width.
She just made
width times
she
half.
just made a triangle. So what do we do for the formula of a triangle?
No.
No, we cut it in half. So length times width divided by 2, right? Okay. So that's how you know that's the formula. It's half of a rectangle, so you're cutting it in half. So whatever the formula is for the rectangle, cut it in half, and there's your answer for a triangle. Does that make sense?
So our area is going to be, what's our length? What did they tell you in the problem? What's the length? Read the problem. The length in the problem is
3x plus 2.
3x plus 2, thank you, times the, why does it say height? Shouldn't that say, well, that's okay.
Same thing.
Base times height. What's the height or the width?
X minus 2.
X minus 2. And we're going to multiply that out, but then what are we going to have to do at the very end?
Divided by 2.
Divided by 2. Let's do the double distributing first, and then I'll help you with the divide by 2. It is. Oh, we got it. Go ahead and do the top first, and then we'll divide it by 2. All right, so again, we do our double distributing, go through, and we multiply. We split the first, repeat the second, distribute 4 times, combine in the middle. The only thing that's different is now we have to take that, divide it all by 2. What did I do? I wrote my trinomial all over 2. Done. Finished. There's the area. Okay? We're not able to actually figure out a number. There's x's in there, so we don't know. All right? All right, the last one that I'm going to do is we're going to do this one together. I'm going to let you guys try this one on your own. Okay? And then we've got a little exit ticket to see where we stand. Okay? What's different about this one? This is the challenge problem for the day. Challenge problem. What's different? What are we multiplying? A what and a what? A binomial and a trinomial. We're still going to double distribute. We're going to do a lot of multiplication here. Okay? Are you ready? Let's do it. Split the first term. So, right kind of small. 2x goes out here. And then I've got my positive 3 goes out here. But this time, my second term is a trinomial. Okay? So my second parentheses is 4x squared minus 5x plus 10. But how many times am I going to write 4x squared minus 5x plus 10? Twice, because it's the second guy, which means we write it twice. So not that different. The second guy writes twice. What is going to be different has to do with the multiplying. When I go in and distribute, I'm not just going to distribute 4 times this time. I have to distribute how many? How many times are we going to distribute on the first one? 1, 2, 3. And then we're going to do it again. 4, 5, 6. Woo! It's a lot of multiplying. Lot of multiplying. 2x times 4x squared. Is it, Daniel, did you just do that? What'd you get?
8x3.
8x to the third. Why is it to the third?
Because you have to add those ones.
Uh-huh. And what is 2 plus 1? 3. Very good. Okay. 2x times negative 5x. Anybody got that? 2x times negative 5x. Negative 10x squared. And then 2x times 10. Muhammad, I haven't picked on you today. You're so quiet. What's 2x times 10? 20x. All right. Now the next side, we're just multiplying into 3. So we're just multiplying numbers here. Okay. 3 times 4x squared is
7x squared.
times.
Multiplying. 3 times 4 is 12.
We're multiplying. What's the big
That's what I
number?
said.
You
Oh.
added.
You said 7.
I said 12.
Oh.
That's okay.
I thought I said 12.
If that's what you meant, then good. Make sure 12 is on your paper. Okay, 3 times negative 5x is negative 15x, thank you. And then 3 times 10. Now with this one, you're going to have a couple things to combine. Because there's 2 sets of like terms. But that's the only difference. And I have seen this on the STAR test once. So I don't know how likely it is to be on there. I think it's good to talk about. But, I mean, it's not something we're going to do like 5 times on the test because that would be kind of crazy. So if I combine, there's nothing to combine with 8x to the third. So I leave that as is. Now my negative 10x squared and my 12x squared, I can combine those because they both have an x squared. Okay, and that'll give us what? Negative 10 plus 12 is?
You get to use your calculator, guys.
Negative 10 plus 12 is? And then 20x minus 15x is? 5x plus 30. That's a lot. All right. Try the next one. You guys try. Okay. So those were a lot.
All have signs.
Those binomials and trinomials, they're a lot. I know. Okay. So our plan now, if you'll get your Chromebooks out, you got some space on the last page. Last page here. For time purposes, let's just use this back page of your notes. There is an exit ticket. It's 3 questions long. Okay. That I want us to do. It's linked right here on the Canvas calendar. It's only 3 questions. When you finish, I have a polynomials little maze for you that has to do with some multiplying. So you get a problem, you multiply it out, which answer tells you where to go next. And it's only like, I don't know how many problems it is, but you got some workspace here. So let's do the exit ticket first so I can get some data, know who needs some help on review day with this type of stuff. And then when you're finished, you can pick up one of these. Or I'll pass these out, okay? It's not all the problems, though. Because you only go, you find the right answer and you go to the next one. It's only like 6 or 7 problems, I think.